So in the previous video, we just found out how long and where these tractors will collide with each other if they are going the same direction. But what happens now if we take this red tractor and switch the direction of its velocity, making it go towards the green tractor? It's going to collide a whole lot faster. But we, once again, are going to figure out what's going to be happen. And just to assure you, the tractors are once again empty, so no one will be harmed in the making of this video. A bigger eraser tends to erase things faster, evidently. Who knew? Okay, so to start this problem, we once again are looking for time, so we got our velocity equals distance over time, but we want time, so we rearrange it. We get time equals our distance over our velocity. But the difference in this problem is we have to figure out what our velocity is going to be. Once again, let's look at it as if we are in the green tractor and the red tractor is going towards us. Now intuitively, you can see that the 15 miles per hour are going in one direction, the 10 miles an hour are going in the opposite direction. So if we think of this tractor standing still, and so if this is a velocity of 0 here, we can think of it instead as the red tractor gets added the 15 miles that were on the green tractor. So the red tractor is now going at 15 miles per hour plus another 10 miles per hour, making it a total of 25 miles per hour. And then we think of it as it's going to collide into something 0.5 miles away. I'll put these back so we still remember what the problem is. So now, since we have our velocity here, we can just plug this into the velocity in this equation, and then we get our distance of 0.5 over 25, and then we take a moment to calculate this. So plug into your calculator, see what you get, and we get 1 over 50, which equals 0.02. And so then for our units, once again, let's think through this. It's always good because when in doubt, just write your units out and it will make the problem make sense. So we have our velocity underneath our distance. So our distance is in miles. And we have that over our velocity, which is miles per hour. The miles, once again, cancel each other out. We have 1 over hour, which equals just a plain old hour. So we are going to collide in 0.02 hours. It's a lot faster when they're going towards each other. But now let's once again think about it. If we have our starting point here once again at the green tractor, how far away from the green tractor's starting point are these two tractors going to collide with one another? So we go again back to our simple equation over here, but instead we're solving for distance, which is our velocity times our time. And we have our time right here, 0.02 hours, and we're going to multiply that by our velocity. Not 25 this time. This time we're doing the green tractor because we want to know when the green tractor is going to hit. And it's going to hit at this time going this speed. So we have our time times 15, and that will get us a nice, so 15 times 2 is 30, but we have to count our decimal places, so we get 0.3. So we have 0.3. What are our units again? I know this is getting kind of old, but just keep doing it. We have to make the point because we have our 0.2. This is our time in hours times 15 are miles over hours, which equals miles, because hours crosses with hours and we're left with miles. So our distance is 0.3 miles. So looking at this here, red's going slower, green's going a little faster. They're going to collide right about here. And that is the end of this problem.